Hi, this is Robert from Part Fusion. Last week I was describing flicker issues I was getting from my LED lighting strips, and I suggested this circuit diagram as a possible solution for driving the LEDs myself, which would reduce any flicker visible on the camera. So what I needed would be a power supply, a current regulator, and the strings of LEDs. I was able to break the light bulbs open and take the long strips out of the tubes, and I was able to then cut them down into 28 LEDs, strings of 28 LEDs. That's where the normal connection was. So I was just used cutters to cut and break the aluminium printed circuit boards together. So I then needed to figure out how much current and what voltage I needed to drive the LEDs. So I made up this other circuit board. So this is just a kind of a variable current source. So as I connect the wires up to each of these pins, I get a different current flow, so 10 through to 60 milliamps. I then was able to connect my multimeter across these LEDs, and as the current flowed through the string of LEDs, I was able to measure the voltage drop across the small string of LEDs and then each individual LED. The reading I got at about 50 milliamps was 2.87 volts on average. Multiplying that by 14 gave me a 40 volt voltage drop. 14 was half the string, so it seemed like a reasonable target value. 40 volts isn't a normal voltage that we would use in kind of hobbyist projects. Usually it's kind of 5 or 12 volts, but 28 volts is a relatively standard voltage level. It's used in telecoms. So I was able to order a 48 volt 1 amp adapter module like this, and then I could use that to be the power supply in this circuit. I then wanted to try different configurations of the number of LEDs in a single string to kind of either have the light concentrated or to kind of spread it more out. So here I've got 14 LEDs. I've got the constant current regulator chips here. I needed to double them up to get the 50 milliamps that I was the target current. So here's them just 14 in series, and here's 2 and then a gap, 2 and then a gap. I just used a small bit of wire and solder to jumper over the LEDs that I was just able to cut off with a side cutters. And here was a 2 and then a double gap, 2 and a double gap. So those were 3 configurations that I had tried. So this is one of the resulting light boxes that I created. So this has 5 of the strings. I'm using just a solid wire then to kind of form a positive rail and then a ground rail. This is made of cardboard. And if I connect my this circuit up to the voltage power supply, I get a very, very bright directional light. It's too bright to look at in person, so I have done some experiments using tracing paper to try and diffuse the light and make it a little bit more bearable. Another configuration I tried was to make my own LED strip. So here I've mounted 5 of the LEDs onto a piece of aluminium. And my last configuration is I have 14 of the strips in this lighting box. The 5 strips have a light output of about 1200 lumens, and this 14 strips has about over 3000 lumens. This one is very difficult to look at in real life. So I'm going to continue my experimentation to try and come up with an adequate lighting array for the upper level of my my lighting camera frame, and I'll report back next week. Thank you.